In this video, I am doing another related rate problem. So take a moment and read the problem carefully. Okay, with this problem, it would be probably helpful to draw a little picture of what is going on. So you've got, let's see, a Cessna 208, which is heading north. So I'm going to draw a little arrow heading north. North would be at the top of the page. And it is 143 knots. So that's some information that we're going to be needing. And then there is another airplane, a Lear 35, that is heading directly towards the Sedona airport from the west. And so I'm going to draw that with an arrow from the west. So that means it's going from the, which would be from the left. And of course, right here, there's the Sedona airport. And it is going at 410 knots. According to the radar, when the Cessna heading north is exactly 80 nautical miles. So that would be 80 nautical miles from the airport. The two airplanes are 261 nautical miles apart. Well, that would be this distance right here. This would be 261. So let's call this, because this is a vertical distance, let's call this X. Let's call that Y rather. Let's call that Y. And then let's call this distance X. And so now let's identify what information that we have. So if the Cessna is 80 miles from the airport, and this is a distance Y, we can say that Y is equal to 80. Now the rate at which Y is changing is the airspeed of the airplane. So dy dt is a rate, and that rate is 143 knots. Well, likewise, at the point where this is 80 miles, this is 261, this would be a distance of X. We don't know what that is. But the rate at which the Lear is coming from the west would be dx dt, and it is 410. So there's a couple of things we need to find. First of all, we're going to need to find X. And we actually have three pieces of information. We're used to only having two, but we actually have three pieces of information. In addition to the fact that we know that this is 261 down here, let's call that distance D for distance, capital D. So I could say that D is 261. Well, when you look at this, you'll notice that you have a right triangle. And we're not given any type of an equation to relate these things. And we don't need one, because what we're going to do is we're going to use the good old Pythagorean Theorem. And the Pythagorean Theorem, in this particular case, would be d squared, the hypotenuse squared, is equal to one leg squared, or x squared, plus the other leg squared. That is our basic equation. And so what is it that we want to find now? How fast is the distance between the two airplanes changing? That would be this distance in here. How fast is that distance changing? Well, if that distance is d, then what we are doing is we are looking for d dt. That is what we need to find. And so we can do that by taking the derivative of this equation based on the Pythagorean theorem. So the derivative would be 2d times dd dt is equal to 2x times dx dt plus 2y times dy dt. Well, we can factor 2 out of the right-hand side because you can see that both of these have a 2 here. And then that will cancel with the 2 here. And then what I'm going to do is I'm going to take this d and I'm going to divide it into the x and the y. And so I will have solved for dd dt. That will be equal to x over capital D times dx dt plus y over capital D times dy dt. Now it comes time to substitute information in. And so we know what dx dt is, we know what dy dt is, and we know what d is. What else do we know? Let's go back to our information. We know what y is, but we don't know what x is. We know what y is, but we do not know what x is. Well, we can find x also using the Pythagorean theorem. At this snapshot in time, what we're doing is we're looking for when this vertical distance is 80 and the hypotenuse is 261, what is x going to be? Well, using the Pythagorean theorem to do that, we can simply say that 261 squared is equal to 80 squared plus x squared. Solving this for x, we get x is equal to the square root of 261 squared minus 80 squared. And then you can evaluate that using Desmos, and you will end up with a value of, I believe it was 248.43. 248.43. So now we can fill in everything that we need here. So dd dt is equal to x, which was 248.43, divided by the distance d, which was 261, and times, I'm just going to put it in brackets, 410, which was dx dt, plus y, which was 80 over capital D, again, 261, times dy dt, which was 143. And so we end up with the rate of change of distance with respect to time being equal to 434.09. And that is the rate of change of the distance between the two airplanes with respect to time. It is changing by 434.09. And that answers the question for this problem.